Sorry, dealing with question 11, I ran out of space in my phone there. So we have this quadratic here, but we're given b as a coefficient. That's what we've got to solve, that's what we've got to find, but we're told it has one root. So that means that when you have the discriminant, it's going to equal 0. So what we're going to do is we're going to substitute all these values in. So we've got b, we've got 4 times 1 times 25. So b squared is 100. B squared minus 100 is equal to 0. B squared would be 100. And when you square root 100, you get plus or minus 10. So that's your two different values for question number 11. Okay. Question number 12 is the converse of Pythagoras. Now, you can't set it up like you would a Pythagoras sum. So what you've got to do is you've got to find the longest side and square it. You've got to find the other two sides and square them and add them up. So I've found the longest side, I've squared it. The other two sides and added them up squared gives me this. And then you've got to make a deduction from that. And it says that 1521 is not the same as this. Therefore, it's not a right angle by the converse of Pythagoras. And you've got to be fairly specific in the way that you write that down. Okay, so you can't just write it as a squared equals b squared plus c squared, because then you'd be making an assumption that it is right angled, and you can't do that. Question number 13, I've got y equals a cos bx. Now, a is the amplitude, it's how far up and down it goes. So if I do 4 minus minus 4, that's 8 of a difference between the top and the bottom. And if I divide that by 2, it's 4. Now, the reason I've said that is because if it's shifted up, it's not just necessarily where it starts up here. You've got to also look at how far down it goes, and it's got to be half of the distance between those two bits. Okay, so question number 13, 4 is going to be A and B is going to be 6. So that gives you your two values for that. And that's it finished. I hope that's helpful. Bye.